Better Buildings for Humans is powered by Advanced Glazings, makers of the Solera line of products. Solera is the leading glass glazing made specifically for architectural daylighting and with extreme insulation performance. Learn more at advancedglazings.com.
Well, hello and welcome to this week's episode of Better Buildings for Humans. This is the show where we talk about the impact that the built environment has on our health, our wellness, our productivity, our energy levels, our joy, our happiness, and of course, we always talk about sustainability as well. Today, I have a very interesting guest. You know, I love to talk about light and lighting. I've got Scott Zimmerman from Silas Inc. And Scott has got some interesting stories to tell about lighting and about LED lighting. Scott, welcome to the show. It's a pleasure to have you here.
Thank you, Joe.
Scott, you've spent more than 30 years in lighting and optics. And I look at your resume, you've managed to have an incredibly diverse career in what some people would think is a relatively narrow field, but you've done some really interesting things. Tell us about your career. And please include the path that led you to Silas and the kind of work that you're doing now.
Well, I started out as a mechanical engineer working in an avionics outfit. And someone once, at one point in time, someone said, hey, we need to start looking into the effects of making better displays and EMI effects and antenna design. So it kind of shifted me over into more of the optics and the radiation type work that I spent basically most of my career doing. And along that path, I got pretty good at coming up with new ideas. And the company sent me back to the research center there and back here in New Jersey to develop new products out of their research group. And I had the honor of working with about 350 PhDs. And I'm the one little engineer walking around saying, well, let's make this, let's make that. And, you know, it was just an amazing process and one that doesn't occur very often much anymore. But along that line, they influenced me in how I think. You know, and that continues even today, working with people like Glenn Jeffrey and Bob Fosbury and people and Roger C. Holt and Russ Ritter. You know, it's kind of like a training process, I guess I'd say. And then I got involved in doing it more and more in lighting. And then I started saying, you know, I'd like to make a new kind of light source because there was indications that there were health issues associated with LED lighting and CFLs along the way. And so I started up Silas, and Silas is mainly focused on its primary focus originally was basically to develop new lighting that was healthier. Having interviewed people like Hamlin and other people that were doing all this work, because you look at the literature and you see all this stuff going on with red light therapy and blue blockers, and you get the impression pretty strongly that there's something where we're missing. There's an absence or an anemia. And then I started doing some of the models around, because I do quite a bit of optical modeling, models around what was going on in nature. And all of a sudden you come to the realization, hey, you know, we threw away 90% of the solar spectrum, you know, over the last few decades. And so I keep on saying this and people maybe get upset about it, but, you know, we're going through the largest reduction in solar exposure in human history, along with the largest increase in artificial light exposure at night. So those two things are basically shifting all these ratios around by essentially eliminating large portions of the solar spectrum. And then, you know, and I was lucky enough to team up with Russ Ritter and do the paper on optics of the human body and melatonin. Russ has been working in melatonin for 40 years. He's had 100,000 citations. And, you know, we started putting together some papers. And just the point is that, you know, the IES actually asked me to write the original paper for them. But then when they saw the content, they banned wouldn't publish it, and actually deleted all my comments on the stuff with Ian Ashdown and others. So we went to the medical journals and we published in medical journals. And I think it was actually a positive thing that the IES got nervous, because it forced me to be a little bit more disciplined. Russ helped me, you know, write a journal worthy paper. And then Honestly, what happened is that my granddaughter got neuroblastoma, and that changed my kind of perspective. So I started focusing more and more on trying to understand the medical aspects of light. And when you do that, you start to see that the body goes to a great extent to collect and localize certain portions of the near infrared and other parts of the spectrum in ways that are truly humbling in a lot of ways if you're an optical engineer. I mean, there is some amazing optical processes that we can talk about a little later that, that clearly make it that the body is going to a great extent to try and use the entire solar spectrum. And that was what I started working with. And after that, I started working with Russ also on a new paper that we did for biology that showed that the pineal gland is not really the major source of melatonin, that actually all our cells are generating melatonin. It's just how we measure it that is a little bit wonky. And, we showed a transient response and things of that nature. So, it's kind of running counter to a lot of what the lore is out there. And it's not saying that I'm anti circadian. I'm just saying it's been oversold and it's a little bit misguided at this point. And I think that's a fair assessment because there's been a lot of trouble getting circadian systems to be of any real benefit, practically speaking, and to do it and how to do it properly. But we can talk about that a little bit. But, and then I started looking during COVID, so I kind of shifted the company more to we're making a product that we believe mimics outdoor light, but we're also very focused on trying to understand the underlying processes mechanistically so that we can, see why is the body doing this. And it's been like I say, it's been a very humbling approach because you see how infantile our understanding is of some of these things that the body is doing. So, and I did publish a paper during COVID where we showed that the main, if you look at it, 99% of all infections, whether COVID, influenza, whatever, occur indoors. And that is easy to understand if you look at what the nature does outdoors. Outdoors sunlight is generating certain reactive oxygen species during the day and at night that tend to suppress the transfer of diseases to pathogens through the air. And we did some great computational fluid dynamic models showing how, near infrared, how the near infrared component and the other and the sun and sunlight and UV is effect sets determines how fast things are transferred. But and we did two models basically showing the effect of disease pathogen transfer between two people as a function of exposure to the atmosphere and exposure to sunlight. And then we were also able to show that the body takes advantage, is actually more likely to reject or fight off an infection if you're outdoors. And that's what I've been trying, to get more of that defined so that maybe the next time we have an outbreak or a pandemic, we do smart things rather than stupid things like we did with COVID by putting everybody indoors in close proximity to each other and give them some other options. I'm not against vaccines. I'm just saying, why would you make it put people in the worst possible situation when you don't need to? And then here in the later, I've been, like I say, working with Glenn and Joe, or Glenn and Bob, and they're working on trying to bring this all together into kind of a better understanding of how sunlight interacts with biological systems. It's a unique arrangement because Bob is an astrophysicist. I'm an optical engineer, and Glenn is, the world's expert on biology. And so it's been probably the best, most fun thing I've done, I don't know, in a long time because they're stellar people and they also really believe in science and aren't afraid to go a little bit over the edge to understand what's going on. So,
Yeah, absolutely. It was an amazing interview with Glenn for sure. You said several things there that I have to pick up on a little bit before I move on. First and foremost, what a profound statement that we're now in the middle of, or at some significant point in the largest deprivation of solar exposure in humanity's history, and simultaneously at the largest exposure of artificial light in humanity's history. So yeah, that is really profound, and it's something that we've completely ignored. I mean, when I started this podcast, everybody talks health, we talk about exercise, we talk about diet, right? And we don't talk about the impact that this artificial environment that we live in has on us. And that statement was incredibly profound, so I really wanted to make sure that we emphasize that. I want to ask you another question, though. You talked about the spread of disease. I'm getting way ahead of myself, but I just have to ask, had we been had COVID come at a different time when we still had incandescent lighting, in your opinion, would it still have proliferated the way it did? Or is that just
well,
too much outside of your expertise to answer that question?
no, I mean, it's clear that incandescent would have provided some benefit to what's going on. But if you do the model, what you find is that, and like I say, it's extremely humbling when you look at what nature does. I mean, the blue sky above us, which everybody says blue bad. Well, that blue sky above us, we can survive in for hundreds of years. And it actually is not just blue. The majority of the UVB and UVA that we absorb in our body is not coming from direct sunlight. It's actually being scattered out of the atmosphere in the same way that blue is being scattered. And that way we get essentially exposed in all directions to kind of deal with all this stuff. That, is a kind of a profound statement in itself. And that's how nature, it takes these dilute, as Bob likes to say, dilute low entropy photons, so high quality photons with energy, and it hits the atmosphere and it essentially expands it into this 2 pi steradian hemisphere above us that we see as the blue sky. And but that blue is also, Rayleigh scattering is basically a function of wavelength. So there's actually more UV being reflected into that hemisphere than there is blue. So, by everybody's argument that we should need to block the blue, need to block the UV, the problem is it's not blue and UV are bad. It's that they're always in nature provided with a background of near infrared. And it is the near infrared component that allows us to operate in this wonderful environment that we're in by reflecting, absorbing. The trees were here first, so and plants were here first, so they absorb and use the reds and the blues to do photosynthesis, but they reflect the greens and the near infrared strongly, almost 90% in some cases. So we're walking around in this environment where we've got blue and UV up here and around us, and then all this our surroundings are bouncing in the near infrared into the body, and the body is amazingly attuned to collecting those different portions of the radiation and from sunlight and using them, and then eventually going down to converting that into heat that then is a very high entropy situation that essentially exhausts out through the mid infrared into the space so that we can essentially keep a balance going. And that's one of the things I think people, if I could get anybody to understand anything, everything in nature is a balancing act. We like to look at these experiments, even Glenn's experiment, which was a great experiment, is looking at one little chunk of what the body has to deal with. The body is simultaneously dealing with thousands of different inputs and using feedback loops, positive and negative feedback loops, to control and make it so that we can survive. Now, when we started messing around with throwing away huge portions of the spectrum, we started taking away some of those counter yin yang things that are going on in the body. And that's what I think is so frustrating about the DOE's work is they're so focused on energy. It's at all costs. And in reality, they are causing us to expend huge amounts of energy on increased healthcare and putting people in position where they're getting negatively affected. So I don't know if that answers your question, but you know.
Very much so. Yeah. Well, it certainly speaks to the larger picture, and I couldn't agree more. If I think it was Lisa Heshong that said recently, if your only focus is energy, you're going to manage energy. But perhaps we should recognize that there are other aspects to survival than just energy. So this is where the architects kind of take over from the engineers at a certain point. Okay. Let's rewind and just kind of go back to the beginning. What is lacking in conventional LED lights, and what harm is being done by that? Just, we kind
Okay,
of
well,
danced
first,
around it, but let's dive right at it.
okay, well, first and foremost, narrow band emitters like we get out of LED and complex fluorescent do not occur in nature. Everything in nature is broadband. Everything, we are never exposed to blue photons or UV photons without an excess of near infrared and mid infrared and shortwave infrared, and people like to unfortunately classify that as heat. It is no more heat than blue or UV. You deal with it, you look at it and measure it in optical watts versus lumens because we don't have an eye response. And so what happened with the LED lighting is that they made the assumption that 90% of the solar spectrum was of no use and that they could get away with just providing visible. Now that made it so that they could make things more efficient as far as eye response. But like I said, blue doesn't occur in a narrow band like it is shown in most LED systems. And I totally agree with blue blockers. If you're going to look at LEDs and you're going to be in LED lighting, then it's a shame that you have to give up blue because we can obviously deal with it in nature. But if you're going to force everything to fit in the DOE standard of 120 lumens per watt rule change that they're trying to force everybody to shove down everybody's throat, then you don't have a choice. You have to give up some blue. And you may have to give children blue blockers in order to do it because that blue is harmful. And that's just the way it is. And the same thing can be said about the greens and the yellows and in some ways as well, because what you've done is taken something that is very broadband and very containing huge amounts of near infrared, and you've replaced it with something that only provides stimulus in the visible. Now, it turns out that our work in melatonin has now expanded into cortisol because what we found is that and this is out of Ray's work, is that if you expose people to just visible only light, then you tend to stimulate high levels of cortisol. And cortisol is a great thing. We all need it. It's supposed to be the fight or flight response. And so, if you get flashed with a bright light or you see the landslides coming down on top of you or the tiger's about ready, then you need your cortisol and adrenaline to kick you up. The problem is that melatonin, and this was the paper that I did with Russ that showed the transient response, is that when we have that event, cortisol jumps up. Guess what? Middle of the day, doesn't matter what time, melatonin jumps up. The problem is that everybody's been measuring it on the wrong time constant. And so they didn't see that melatonin is actually in the 9 a.m. in the morning. I can cause melatonin to go 4 times higher than what you get at night just by simply doing some exercise, going outside, making love, doing whatever, doing some kind of a stressor. All of a sudden, melatonin goes up too. And the point is that melatonin tends to suppress ACTH, which then it's meant to suppress cortisol. And so it's just kind of like a yin yang type thing. And then what appears to happen in nature, if you're in a natural stressor, is the body is attuned to essentially try to drive down cortisol, but it maintains a little bit of excess melatonin. So that feeling you have when you went out to the beach, why do I feel sleepy after being on the beach? Why do I get a little bit sleepy after a good exercise or anything like that? Is the excess non-pineal melatonin in the body that is generated by all the mitochondria. Bear in mind, there are trillions and trillions of mitochondria, vastly outnumbering the pineal gland. Doesn't mean the pineal gland isn't important. Pineal gland was selected, and melatonin was selected by the body to kick in extra melatonin because we need to use our brain at night, 80%. So it's generating all kinds of reactive oxygen species. And that melatonin is there to help the brain function properly and provide a little extra out to all the cells that didn't have enough from the day. And so much of our lifestyle now is essentially doing exactly the opposite of what occurs in nature and creating this problem that people have with sleep disruption. And that was one of the things that I think is so interesting about all the red light therapy that's popping up, and diet and things of that nature. The body's designed to handle a wide range of things. There's hundreds of thousands of different diets that people are on around the world. We all live about the same amount of time in most cases.
Right.
And the same is true with not only with what we eat, but the environment we're in. The one thing that it is so frustrating about all this stuff is everybody has a long list of things that are bad for us to do, but light is just not on the list. Sunlight, the amount of sunlight exposure just is never on the list. So anyway, again, I'm not trying to answer your question completely, but that's kind of what we're kind of seeing right now.
What are the health impacts then, Scott, that you and your contemporaries saw as a result of the missing near IR?
Well, mainly the problem, you look at it from a fundamental standpoint. It's not just one thing. It's almost the entire list you can link up of modern ailments and maladies that we're having can be leaked in some fashion to. In Glenn's particular experiment, he used some red LEDs on the back, small area, hit it for about 15 minutes, and was able to show that the ATP production was more efficient with a little bit of near infrared. In so many ways, the uniqueness of the near infrared component that we took out is that it penetrates deep into the body, inches into the body. And if you've ever seen Bob Fosbury's picture of his hand where he puts it over 850 nanometers, the higher hand does. I keep on trying to tell people, take your cell phone, put your thumb over your cell phone, go in a dark room, turn it on, and you'll see your entire thumb glow red. Yet if you look at the lit, they say that you can't get more than a millimeter into the body. It's just because they don't know how to measure diffuse structures like what we are. And so what happens is that because it penetrates so deep, a high percentage of the cells that we're made up of see near infrared and use it to enhance ATP production, which then translates into better, use of glucose and all these other things. And over time, that all adds up. So it's kind of like a chronic exposure situation. So, I would say that specifically sleep disruption is tied into this whole thing, because I don't know about you, but I used to put up hay when I was a kid. After you were off, spent all day out putting up hay, you slept really well.
Oh, yeah.
Versus sitting in front of a computer that's bombarding you with basically stimulus. I don't know if you ever had any grandkids, but I have grandkids, and all you have to do is walk by a TV that's on, and the kids lock on to it. And
Yes.
and part of that is there is it. The mafia figured this out decades ago. When you walk into a casino, what happens? There's flashlights, lights flashing. There's noise, all making noise, giving you liquor. And they're not doing it because they're just fun. They're doing it because it translates into you reducing your risk, because your cortisol and its associated dopamine response is enhanced. So they are manipulating your hormone levels to get you to spend more money. And that is kind of just the way it is. Well, the same thing is now happening. TVs are gotten bigger and brighter, and it's more contrast and more action films that just lock you in, because that's the function of cortisol. And cortisol is almost always accompanied by a dopamine, which creates an addiction type thing to where we're kind of locked in. So our lifestyle is basically part of this whole equation, I guess, as I'd say.
Okay, so how is Silas's products going to assist in resolving the issues associated with not having the full spectrum light available?
Well, The body, I mean, if you look at it from a joule standpoint, 30 megajoules are basically, if you're outdoors all day, you can receive up to 30 megajoules in a day. Okay. If you're in shade, it's about a tenth of that, maybe down three. And then by the time you get down into a house or inside, you're down to kilojoules per day. Okay. What we're trying to do is we're not trying to match sunlight as far as the intensity levels that are involved. What we try and do is always maintain the near infrared in optical watts to visible watts ratio that we see when we're outdoors, either in direct sunlight or in shade. So our goal is always to make sure there's more near infrared than there is visible in our light sources, because that's what happens in nature. And over time, you think about, okay, I go out for 10 minutes in direct sunlight or 15 minutes in direct sunlight versus, okay, I'm indoors, but I'm exposed to lower levels, but I'm exposed for 8 hours. I'm stuck in front of this laptop for 8 hours. Our idea or our products basically make a desk lamp that sits next to your computer that essentially provides you with a lot of near infrared, to your point. And our light sources are very simple. They're simply hybrids. We use LEDs to make visible because LEDs make really good visible. We use little filament bulbs, incandescent filaments, because they're the most efficient maker of the near infrared. And we control those in a ratio such that we mimic basically the conditions when you're in shade. When you're in direct sunlight, the near infrared to visible ratios in optical watts is about 1-to-1 at high noon. As you get towards the evening, it shifts a little bit to more near infrared. If you're in shade, because they are absorbing portions of the visible and reflecting portions of the near infrared, your little walk in the park is ideal because it kicks the ratio up to about 3 to 5 to 1. And then if you're sitting out in front of a campfire at night, it's 10 to 1. So we're always trying to maintain that ratio coming out of our light. And we do it in a single source with a diffuse thing because I believe strongly that you don't want to look at emitters in any of these cases if you can avoid them. I mean, the worst light bulb I think ever invented has been the LED filament bulb that everybody uses because it's imaging. The retina is responding to huge changes in the focusing that filament, even the glancing away. It's focusing that filament on the retina, creating very high levels of effect. But it's doing it, and everybody thinks, oh, it looks just like an incandescent filament. It's not even close. It has, because at the same place that the incandescent filament is providing near infrared to that region on your retina, at the same time it's providing the visible that you respond to. So, like I say, I think the worst light source ever invented has been that little LED filament thing, because I think it's really creates a lot of problems. And we got the myopia epidemic, which is associated with too much blue, not enough red. It's not that there's too much blue, it's that there's not the proportional amount of red and near infrared. And in the near infrared, the eye is just this amazing thing. Everybody thinks about the eye as an imaging thing in the visible, where the light goes through the pupil. But in reality, the majority of photons that hit the retina don't go through the pupil. They actually go through the sclera and the eyelids because they're translucent in the near infrared, and you have higher levels of near infrared when you're out in nature. So it's this amazing non-imaging optic and imaging optic in the same thing. That's what's really amazing when you look at it. And so, yeah, again, that's I'm not sure it answers the question, but anyway.
Very much so. Look, obviously, I'm a strong proponent of full spectrum natural light from the sun. I mean, you have everything that our bodies want in full spectrum natural light. And of course, it doesn't require you to consume any carbon in order to use full spectrum natural light. So, sun first, but this sounds like a better solution where in scenarios where you can't get sun into a particular area in the building. Is that a fair statement?
Yeah, but I mean, I think it's almost like a movement that we need to do to where we need to get people to appreciate. I mean, a simple little desk lamp next to this laptop. that's putting out, we put out 4.5 optical watts of near infrared, 1.5 optical watts of visible. I chose that selection because of shade. I also chose it because I did work with Professor John Louis on the black population, because they're the ones that actually need higher levels. They need about 3 to 4 times the stimulation to get the same response as someone with lighter skin like you or I.
Right.
And then also children, because their physical size is smaller, more of the near infrared when they're outdoors penetrates in and stimulates their cells. They also are going through huge hormonal changes that I think are very critical. And so I started out this, though, I was just trying to make a better light source. Now I'm trying to replace a really lousy, harmful light source.
Right.
And that's what I believe. And that probably doesn't make people happy, but I think that we should literally not allow children to be exposed to LED and TVs without some level of near infrared being thrown into the mix, because honestly, we don't know enough to actually say that it isn't harmful. And there seems to be an uptick in a lot of diseases that coincide very strongly with, or correlate very strongly with, the timeline. Because it used to be, kids would go outside. You and I would go outside and we'd build a tree fort, or we'd do outside, we'd beat stuff out. Now everything is indoors under artificial because it's convenient, it's so easy. You don't have to worry about it raining and all this other stuff. So if you look at the total of exposure, it's just, we've gone through the roof. We've basically driven the ratio of near infrared down and visible down to zero. And because not only is it our displays that are doing it, but the windows, the glass that we have on the low E glass that's been mandated by the DOE blocks almost all the near infrared. And it's just a shame because that's free, and I guess it's not free in that they claim that they need it for energy savings. But the architects we've been talking to, they have other solutions. They have light tubes. They have other things that they could do that is much better. But I say it explains a lot of the problems we have with CEOs, the fact that they have a corner office with glass that blocks all the infrared.
Yeah.
They're just dumber than the rest of us.
Well, and it's such an incremental, tiny improvement in terms of energy performance, that low E coating. Yeah, it's 50%, but you go from R2 to R3, and that's just center of glass performance. So, in terms of the
Yeah.
overall, when you throw in the overall system, R value, it's a really minor improvement in energy performance with a corresponding detrimental health impact. So yeah, it's kind of a bizarre thing. I'm kind of with you on that one for sure. How are you spreading the word on this, Scott? This is potentially monumental. Everything to me points back to my mission in life, which is bringing natural light into spaces, and all of this supports. I'm not crazy. I'm doing good things for sure, and that makes me very happy to hear. But there are scenarios, including northern climates or northern and extreme southern areas, where it gets dark for much of the year. I've spent winters in Amsterdam where the sun goes down at 3:30, and you need the artificial light for a significant portion of the day. So what you're saying makes sense. How are you getting this out to the market, and how are you telling this story? This is an important
Well,
story.
I'll be honest that it's podcasts like these.
Uh-huh.
I mean, it became obvious that everything I was saying was the antithesis of what the lighting industry wanted to hear. And so I was lucky enough that Roger Seaholt, I don't know if you've ever seen his MedCram vid. He basically provides continuing education units for doctors and nurses,
Okay.
and it's called MedCram. And he picked up my paper with Russ, and he really kind of rolled with it. And now he's done about 7 or 8. He did a podcast or a YouTube video several years ago. It was 2 hours long, extremely intense, and he had 4 million viewers. And, he has then since then kind of jumped on the bandwagon. He's been as more providing more technical than I am, really, from the standpoint. But he's also working with Bob and Glenn and I. And, it's just really hard. We're a little two-person company. We make a light bulb that we make here in the US, and I manufacture them in my house right now, and we're selling quite a few. And we don't argue that it's going to make you better. We just argue that this is what nature does. We're doing it this way. And I still can do 50 or 60 lumens per watt and add 3 to 1 near infrared to visible into the system, given the technology that we have now. And the beautiful thing about it is that it eventually leads to, if you keep on doing it, eventually leads to a very simple, direct, low cost solution. It doesn't require us to invent new technology or do anything. It just requires us to think a little bit about and provide some benefit or some, whatever you want to call it, to near infrared, the rest of the spectrum. And my hope is that eventually we'll get to the point that we add just a little bit of UV back in, because we've got the near infrared to protect people. And then, we're also seeing that I started out, it was mainly the near infrared, like the red light therapy people use, the 650 to 1100 nanometers or whatever. But now we're starting to see that the body's using the 2000 or the 1100 out to 3000 nanometers to actually enhance our ability to generate vitamin D and sex hormones and all this other stuff in the skin, that based on some work by Yakimov and others. So the more we dig, the more we find that, oh, by gosh, the body's figured out how to use everything in that. And that's one of the things that's so cool working with Bob, is Bob looks at it as an astrophysicist, and he's doing the equation from, we start with the sun and we walk all the way down and hits what hits this earth, and the earth transfers, and you go from low entropy down to high entropy, and you're dumping out into space at negative 40 degrees. I mean, it's actually fascinating when you start looking at how, from his perspective, yeah, it just all makes sense. What's the problem? And
Right.
the lighting people are sitting there. I'm still trying to get from 2-dimensional, 3-dimensional. We're not going to worry about energy and all this other stuff. But
Oh, all of it takes me right back to full spectrum natural daylight for sure.
yeah,
But like you said, there's scenarios where artificial light's necessary. Let's try to make it as healthy as we possibly can. We're getting close to the end, Scott. I want to ask you the question that I ask every single guest. It's my universal question, and I ask the guests to answer it from whatever perspective they'd like. What makes a great building?
I think a great building, you touched on it from the standpoint of bringing the light indoors, but I think that we also need to understand that there are trade offs with comfort and convenience that maybe we should think twice about, and this in particular, great building to me, it gets the right ratios of energy from various portions of the spectrum. That's a first step. And unfortunately, there's also this big movement to where they're going to try and filter everything inside buildings with all these air filters and all that. It all it does is create more damage, in my opinion, because it's stripping out the air conditioning and things like that, strip out the natural reactive oxygen species that make up our atmosphere. So we keep on throwing away things that nature put in place to make us healthy. So I'd say that on a big global scale, I just want to add it back in, is what I'd like to do. And the deeper we dig, I'd just be cautious of anything you do that tends to strip out something that occurs in nature. So, and unnecessarily. And it is important that we bring some level of it back into normal, because elderly, you and I, we're getting older, our melatonin's dropping, our cortisol's going up. And so those ratios, and so, from an engineering standpoint, I'd say I would design a building where I maintain the ratios that are in nature, both from light, what we have in our air, things of that nature. So,
I love that. That was a brilliant answer. I absolutely love that. Scott, is there anything that you'd like to promote or any big announcements that you'd like to make?
well, there's two things that are going on right now. We're starting to figure out that the body, if you look at a butterfly wing or anything like that, there's all these little nanostructures. We're starting to figure out the body's doing that and in ways that we never understood, especially in your retina and the layers that go on the thing. So I think that's, from a science standpoint, is really cool. And it is amazing how the body can use that to localize in certain areas a biochemical process. So that's where the new science is going. And then I'd say from our practical standpoint, we're starting to ramp up where we're making more lights. We're making essentially an adapter kit where people can take their desk lamp or their desk or their table lamp or their bed and plug a little wall wart in and run it with zero flicker and has the ratios. It gives you the ability to either run it during the day at 3-to-1 or you near infrared to visible or during a night at 10-to-1, more like the coals from a campfire. I just came back from Maine. We had a great campfire. And that'd be the thing. And then the third thing I just say is if I could convince people that going outside, especially the children, do not go out and fry yourself. Do not go out and sit on the beach with all this junk on you. Go out and walk in the trees. Let your children build a tree house. That's the way to get this done. And if you do that enough, then all this other junk kind of fades into the background, I think.
Very cool. Scott, I can't thank you enough. You and I are going to stay in touch. All right. Take care and thanks again.
Thank you.
We hope you enjoyed this episode of Better Buildings for Humans. For more information on the world's best light diffusing and highly insulating glass glazing, please visit advancedglazings.com.